For RMS 11, a series of new region modeling tools are introduced. Improvements will be made to the fault modeling algorithm, new methods for defining region partitions on the structure, a new region attributes table, and improved region partitioning methods for grids. So let's start with the fault modeling algorithm. In the previous versions of RMS, the invisible extrapolation of faults, which is important for the region partitioning, could create some unexpected results. The fault modeling algorithm has now been improved and will lead to more reasonable results when creating region partitions in the areas beyond the visible gridded surfaces. Rerunning the fault modeling job in RMS 11 illustrates the effect of the updated algorithm on the region partition object. Comparison of pre-RMS 11 and RMS 11. The algorithm now extrapolates the faults based on an estimation of the fault surface curvature. The smoother result gives a more predictable fault block. Let's have a closer look at the structural region partition. In this example, we would like to separate the diamond-shaped block from the rest of the reservoir. This will be done in 3 sequential region partitioning steps. The first step in this example is using a series of faults to start the region partitioning. The Create the Region Partition job can be found in the Structural Model folder. After selecting the faults method, it's easy to select the faults you want to use for a partitioning job. The job captures the fault pattern on selecting the faults. The pattern is estimated based on the fault geometry and truncations, and this pattern is then reapplied every time the job is run. This helps achieve a stable result in fault uncertainty workflows. After running the first job, we can see that we need to use another method to get the partitioning we want. This can be done by using the region mapping method, which is the second step in this example. We now select the option of using an existing partition for input. 2 of the created regions should be reassigned to some of the other regions. Region 3 will be reassigned to Region 1, and Region 6 will be reassigned to Region 7. Step 3 in this example is to use 2 polygons to add the last bits to the diamond-shaped block. In the Methods section, choose a polygon and select the polygon you would like to use as input for the partition job. After running the job, we can see that the correct parts of the region have been added to the diamond-shaped region, and we have achieved the results we were looking for. Know that you can set up any number of sequential region partition jobs and order the methods in the best way to suit your model and requirements. As a rule of thumb, if you require a lot of faults to achieve the desired regions, it is advisable to build up several jobs sequentially rather than adding all the faults in one job. Now that we have the region partition, the next thing we want to do is create a region model. The region model links the region partition with the region attributes table. The region attributes table can be found in the regions folder in the data tree. Here you can assign the region number, name, color, and several different attributes. When a region attribute table has been created, you are ready to create the region model. Simply choose the correct region attributes table and region partition. After running the region model job, we can see that the region model has been linked to the region attributes table with the color table, region names, and numbers. Creating regions for grids has also been made easier, where several jobs have been gathered into one. For grids, we have even more methods of defining regions for the reservoir. For this demo, we used the region partition we created for the structural model to create the same grid of regions. When we choose the region model, it will also connect to the region attributes table of this gridded region parameter. The gridded region model can be used as input for the volumetrics job. We select the region model as a region index input. This means that we can use the linked region attributes table as input for the oil-water contact and for the gas-oil contact. Any changes that are made in the region attributes table will then update accordingly in the volumetrics job where they are used. When a region model has been created, it's easy to create and visualize fluid contact models. You select a region model you would like to use for input, and then the context you want. This is a great way of visualizing the fluid contacts quickly and easily in 3D on maps and intersections. You can use the filter in the Visual Settings dialog to see the contacts for each zone or in one fluid contact at a time. This brings us to the end of this introduction to region modeling in RMS 11.